Packet day 4-5, day 2. Hold your hats. Lots coming at you today. So let's just get her started. This is piggybacking the previous day's lesson where we had this thing going on. They gave you Z1, Z2, and they asked you to multiply them, and then they asked you to divide them. But I want you to look what form they gave them to you in before you manipulated them with these formulas. So now they're going to take one step back, and they're just going to give you this information in standard form. So your first goal is to put these in trigonometric form. And you've done this before, so let's just figure it out. It just takes some extra work. So 1, 2, 1, 2, 3. There's the end of the spinner. And I know this is a 2, and I know this is a negative 3. And I've already done this one, but if I go 2 squared is 4, negative 3 squared is 9, 9 and 4 is 13. So this would be the square root of 13 using Pythagorean theorem. How do I figure out what this is? Well, I like to use tangent because I don't like to involve the square root if I don't have to. And this is my opposite, and this is my adjacent. So I'm going to go tangent of theta is negative 3 over 2, which is just negative 1.5. So we take our calculator. And second tangent, negative 1.5. We've done this exact problem before, but negative 56.3. So that little rascal is negative 56.3. Now, trigonometric form is specifically telling us that our theta needs to be greater than or equal to 0, but less than 2 pi. And don't forget that. So it's a good habit to just stick with the program and say, okay, well, let's subtract that from 360, and I get 303.7. So this guy, I know my r, see Z1 is right here, Z1's right here. So my r is the square root of 13. Here comes the trigonometric form. Cosine of 303.7. And that is plus, and see I'm plus I sine 303.7. See, I found Z1. Now I got to find Z2 because that's what it's asking me to do. So over here, got to do the same thing. I'm going to go 1 to the right, down negative square root of 3, and I'm jumping for joy because I see what kind of triangle this is. What's always opposite my square root of 3? 60, which means this is my 30, 90, which means that's 2. And look at all that information that's coming. What's my r? 2. Cosine of how far I spun my spinner. Don't say 60. Don't say negative 60. It was actually 300. And plus I sine 300. Now that we've done that, we can throw this stuff into these formulas. So what do I do when I multiply these two together? I start by multiplying these two. So I get 2 square root of 13. Now what's this formula say when I multiply? I add the individual thetas. So I'm going to get, watch this carefully now, cosine of 603.7 plus I sine 603.7. And if that's option A on a test, I bet you a lot of you will circle it. And then, bing, you're going to get it wrong. What a shame. Because you got to remember this little rule. This cannot be greater than 360. That's what this is, 360. Well, how do I do this? Well, I'm going to subtract 360. I don't need to do it twice, but I'm just demonstrating that you need to do it for both of them. So I don't want to screw this up. 603.7 minus 360, 243.7. Cosine of 243.7 plus I sine 243.7. All right, I think the subtraction is going to be a lot easier because watch what happens. I mean division, which ultimately we subtract the degree measure. So division, following this formula, see what we do with the r's? We divide, and then we subtract the second one from the first one. So we get the square root of 13 over 2. Cosine, remember, this is the first one, and we're going to subtract this one. So we just get 3.7 plus I sine 3.7. So that's a little bit of a review with a little bit more piled on. That's why it's day 2. What I have not shown you yet, and it's going to hit you right now, is this awesome, awesome, awesome theorem. And look at it, it says, and it's just a printing error, but it says use DeMoivre's. Those of you who took French, you're probably going to tell me I just butchered that. To find the indicated power of the complex number, write your... Anyways, here's my hint to you guys. This guy discovered 2 amazing little formulas that work, and we are going to use this one. This one I think is going to throw you for a loop, so we're going to focus on that one. Now I'm going to try to transfer this to the back side because that's where our work is. R to the n, cosine n theta, don't want to screw this up, plus I sine n theta. All right, there we go. All right, so DeMoivre has saved us a ton of time. Because do you really want to go 1 minus I, like this, 1 minus I, 1 minus I, 1 minus I, 1 minus I, 1 minus I. Imagine if that's a 15. You see, we don't want to do that. So we're going to take advantage of this guy's unbelievable discovery of this formula. And every time we do, we're going to say, thank you, DeMoivre. All right. So R, where's that? Well, that's right here. How come? Because we know this is in trigonometric form. That's where the R goes. All right, good enough. N, N, N. Don't be confused. That's sine. This is the N. What is the N? N is going to be the power. And then I know I've got a fancy little blue one sitting around here somewhere. What is theta? Theta is right here. So once you figure all these little pieces out, sorry about that, get you dizzy, just plug stuff in, plug and chug. So we get square root of 2 to the n power, which is 3. And then we have cosine n, which is 3, times our theta, which is 2 pi over 3, plus I sine, and then it just kind of repeats itself. Did you notice that? Now we got some math to do. I'm going to take care of these because I love to cross-reduce, a little addiction. And what is the square root of 2 cubed? Square root of 2, square root of 2, square root of 2. Well, I know that this is the square root of 4, which means 2. So this whole thing gives me 2 square root of 2. And then I end up getting cosine of 2 pi plus I sine of 2 pi. Now, I'm going to give you guys a little test. This says answer it in standard form. Am I done? No. But the bonus question is this in trigonometric form? Well, if you think about it, if this is true, then I'd say you got it wrong, because it can strictly be only less than 2 pi. However, instructions don't say leave it in trigonometric form. It says leave it in standard form, which means you just got to figure out what this is and what this is. So we got to spin our spinner 2 pi and draw this imaginary triangle. It's just like what happens at 0. Well, my opposite side is 0. My adjacent side is positive, and it equals my opposite side. So that would mean I would have 2 square root of 2 times, what's the cosine of 2 pi? Well, it'd be 1. Plus, what's sine of 2 pi? Well, because the opposite side is 0, it'd be 0 over my, oops, did I put opposite? I meant hypotenuse. Opposite side 0, so 0 over my hypotenuse would be 0i. And if I distribute, I'd get this 2 square root of 2 weird looking answer, which is the same thing as this, but they don't write it like that. They just write it 2 square root of 2, and there's an implied plus 0i, but I'm not expected to write it. Okay? Crazy stuff. Thank you, DeMoivre's. All right, so now we're going to just continue without all the pretty colors. What's this? That's my R, so that's 4. What's that? That's my N. And now I'm going to put things where they belong. Cosine of N, which is 4, times my theta, which is 5 pi over 6, plus I sine N times 5 pi over 6. There we have it. Now some students prefer the old degrees, so I'll show you. Pi over 6 is 30. 30 times 5 is 150. So a different student may have wanted to go like this. 150 plus I sine 150. Whoops, times 4. Okay, almost made a mistake. So 4 times 4 times 4 is 256. Then I get cosine, what in the world? It'd be 600 plus I sine of 600. I like converting it to degrees, so yeah, I think that's a good route. Well, I need to figure out what these are. By the way, if they said leave it in trigonometric form, would I be done? No, 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 no. This is too much for this. Keep that in mind. But 600, well, that's 360. And I still need to go 240, so I go around once, then I go 180, and I go 60 more. That's where 240 would land me, leaving me with this as a 60. And now I go like this. Now, a lot of students ask, well, isn't this your R? It could be, but we're going to keep it simple. I'm going to really concentrate on cosine of 240. The ratio will be the same, whether I put a 256 here or if I just use my old 1, negative square root of 3, 2. See, the relationship would be the same. If I put 256 here, then I'd have to put 128 here and 128 square root of 3 here. This is much simpler. So I got 256 times, what's cosine of this? 600? Well, it's right here. Oops, almost forgot the negative. Adjacent over hypotenuse. So it'd be negative 1/2 plus sine would be opposite over hypotenuse, negative square root of 3 over 2i. Now I distribute, so I would get negative 128 plus, well, there's a negative, so I should have put minus, 128 square root of 3i. They might want to put that i right in here, so it's not thought of as being underneath that square root, but I'm not sure how they're going to answer it in your answer key. All right. Well, I've only got 2 minutes, so I'm only going to be able to show you how to get started on one of these. So I'll go with this one. So notice, this one gave you the degrees, These two don't. So you have to discover them by plotting that first point first. So I go 1 to the right, and then I go up 1 square root of 3. So this is my 1. This is my square root of 3. And look. It's got to be a 60 and 90 and 30. And there's my reference angle. So what would this radius be? 2. So what I have here is I have R, which is 2. There's my N. And then I'm going to go cosine of N times my theta, which is 60, plus I sine my N times my spinner distance, which is 60. I've got a minute left, so here we go. 2 cubed is 8. This is cosine of 180 plus I sine of 180. Again, let's have a little gut check. What if it said leave your answer in trigonometric form? Could I leave it here? Yes, because this is greater than 0, less than 360. See that important clue there? All right, well, I need to know my quadrantals. So if my spinner went over to 180, my opposite side is 0, my adjacent side is negative, and my hypotenuse, but these two things are equal. So it'd be 8. What's cosine? Would be these divided by each other, so negative 1. What's sine? 0i, because that's opposite over hypotenuse. My opposite side disappears. Distribute, I get negative 8. And that's my answer, which is technically negative 8 plus 0i, so they just leave it negative 8. There you go.